These are the activities for College Algebra Lesson 25. Using the steps below, which have been repeated from the demo, we want to sketch the graph of 1 over x squared. What value is excluded from the domain of 1 over x squared? That would be x equals 0, because you can't put a 0 in the denominator. So x equals 0 is excluded. We're going to use arrow notation to describe the behavior of g of x near the excluded value. We'll use a calculator to do this. So as x approaches 0 from the left, that means my x values are getting closer and closer to 0 from the left side of 0. So we'll start with -1/2. So I'm doing 1 over whatever this x value is squared. So 1 over -25 squared. I'm sorry, 1 over -5 squared, which is 25. 1 over 25 is 0.04. 1 over -1 squared, that's 1 over 1, which is 1. 1 over -0.5 squared, so 0.5 squared is 0.25, and then I have to do 1 over that, and I get 4. And then 1 over -0.01 squared. When I square -0.01, I get 0.0001, and then I have to do 1 over that, and I get 10,000. So it seems as though as my x values are getting closer to 0 from the left, the y values are getting bigger and bigger and bigger, so they look like they're going to infinity. And then let's see what happens as my x values get close to 0 from the right. So 1 over 5 squared, that is 0.04. 1 over 1 squared is 1. 1 over 1/2 squared is 4. 1 over 0.01 squared is 10,000. And again, it looks like the y values are going to infinity. So what is the equation of the vertical asymptote? Well, my excluded value is x equals 0, and my graph approaches infinity as we get close to it. So my vertical asymptote is at x equals 0. Okay, so now I want to explore the end behavior of 1 over x squared, which is what happens when the x values approach -infinity and +infinity, instead of approaching 0 like we did up here. We're going to make the x values get really, really big. So 1 over -1 squared, that's 1. 1 over -5 squared, that's 1 over 25, or 0.04. 1 over -10 squared, that's 1 over 100, or 0.01. And 1 over -25 squared, over 25 squared, that's 0.0016. Okay, and then I'm going to do the same. Oh, and it looks like, so as my x values are approaching -infinity, my y values are approaching 0. And then I'm going to do the same thing as my x values approach +infinity. So I'm going to do 1 over the x value squared. That's my function g of x. So 1 over 1 squared is 1. 1 over 5 squared, that's 1 over 25, is 0.04. 1 over 10 squared, and 1 over 25 squared. And it looks like my y values are approaching 0. So my horizontal asymptote is going to be y equals 0, because the y values are approaching 0 at the far right and the far left. So does g of x equals 1 over x squared have any x or y intercepts? So remember, to find y intercepts, you plug 0 in for x, and we get 1 over 0 squared, which is undefined. So there's no y-intercept. And then to get x-intercepts, in general, for any function, you make y 0 and solve for x. But if I try to solve this equation, I would multiply both sides by x squared to get the x squared by itself, and I get 0 equals 1, which is impossible. so I have no solutions. So there are no x or y intercepts, neither. What kind of symmetry does the graph of 1 over x squared display? Well, first we're going to sketch a graph of 1 over x squared. I've got a bunch of points from these tables, and I have an asymptote, a vertical, and a horizontal asymptote. So my asymptotes are at x equals 0 and y equals 0. And then I have some other points, like I have 1, 1, and negative 1, 1. And I have some other points up here as well. I know that when x is negative 5, y is 0.04, very close to 0. So, and also when x is 5, y is 0.04. So negative 5 point, like practically 0, 5, so close to 0. And then maybe I'll use my negative a half and my half. So the points I'm plotting are this one, and 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 this one. Okay, so negative a half, y value is 4. So I'm going to plot negative a half, comma 4, that's about right there, and 1/2, comma 4, that's about right there. And then I can try to connect these with a nice smooth curve, knowing that the y-axis and x-axis are asymptotes. So this is going to go up and approach the y-axis and come down like this and approach the x-axis. And then same thing on the left, like that. Okay, and what kind of symmetry does the graph display? It looks like it has y-axis symmetry. To confirm algebraically, I'm going to evaluate f of negative x. That will be 1 over negative x squared, which is the same thing as 1 over positive x squared, because when you square a negative, you get a positive, which is the exact original function f of x. So I do have y-axis symmetry. Number 2, the end behavior of a rational function determines where or if it has a horizontal asymptote. So part A, I want to use the graph of the function f of x equals 9x over 3x squared plus 1, graphed over here for us, to determine its end behavior. So as x goes to infinity, what happens to y? So as we follow this graph out further and further to the right, the y values are getting closer and closer to 0. And as I follow the graph further and further to the left, as x is going to negative infinity, the y values are also approaching 0. Which means I do have a horizontal asymptote at the x-axis, which is y equals 0. So this is true in general if the degree of the numerator is less than the degree of the denominator. So this is 9x to the first over 3x squared. The degree on top is less than the degree on the bottom, then y equals 0, or the x-axis, will be a horizontal asymptote. Okay, so B, f of x equals 9x squared over 3x squared plus 1. So I'm following the graph far to the right, and what's happening to the y values? It looks like this graph is leveling off at y equals 3. Y values are approaching 3. And as I follow this graph to the far left, again, it looks like my y values are approaching 3. So I have a horizontal asymptote at y equals 3. And this happens whenever the degree of the numerator equals the degree of the denominator, like in this case. Then the ratio of the leading coefficients of the numerator and the denominator will be your asymptote. So I have y equals 9 over 3. So 9 is the leading coefficient on top, 3 is the leading coefficient on the bottom. So the horizontal asymptote is at y equals 9 over 3, which reduces to 3. Okay, part C, I want to look at the graph of f of x equals 9x cubed over 3x squared plus 1 to determine its end behavior. So I'm going to follow this graph to the right and ask myself what's happening to the y values. They appear to be growing without bound. Okay, the y values are going to infinity. And as I follow this graph to the left, the y values are going down to negative infinity, which means I have no horizontal asymptote. There is no horizontal line that the graph is approaching. This will happen whenever the degree of the numerator, 3 in this case, is greater than the degree of the denominator, 2 in this case. So 3 is bigger than 2, we have no horizontal asymptote. Okay, we're going to sketch each of the following functions by doing a transformation of either 1 over x, which, just to remind you, looks like this, or 1 over x squared, which looks like this. So I'm going to transform those two parent functions in each of these cases. So number 3, I have h of x equals 1 over x minus 5. So my parent function is 1 over x. And I want to describe the transformation. I have the minus 5 with the x. It's inside the function. If it was outside, it would look like 1 over x and then minus a 5, okay? So that minus 5 is inside the function that is the fraction. So we have a shift right 5 units. And the values excluded from the domain in this case would be 5. I can't put a 5 into that denominator because then I would have a 0 in the denominator. So my domain of h is all real numbers except for 5, so I would say negative infinity to 5, union 5 to infinity. So my vertical asymptote is going to be at x equals 5, the excluded value of the domain. We can also think of it as this asymptote in the parent function moved right 5. So it was at 0, we move it right 5, and now it's at x equals 5. To determine the behavior near the vertical asymptote, we're going to look at the behavior near the vertical asymptote in the parent function, but remember that the vertical asymptote is no longer at 0, it's at 5. Okay? So it used to be that as x approached the asymptote of 0, as x approaches the asymptote from the right, the y values go to infinity. But the asymptote is now at 5. So as x approaches 5 from the right, the y values go to infinity. And as x approaches 5 from the left, as you approach the asymptote from the left, the y values go to negative infinity. The end behavior is going to have the same end behavior as the parent. We're shifting the whole thing over 5, but that does not change the end behavior at all. So it's going to go to 0 at the far right and at the far left. So the equation of my horizontal asymptote would be y equals 0. To find x and y intercepts, remember to find a y-intercept, you make x 0. So I'm going to have 1 over 0 minus 5, which is negative 1/5, is my y-intercept, so that would be at 0, negative 1/5. And to find x-intercepts, you make y 0 and try to solve for x. But this equation has no solutions because the only way a fraction can ever equal 0 is if its numerator is 0. So it does not matter what this denominator is. It could take on any value at all. The value of the fraction will never be 0 because the only way a fraction can equal 0 is if its numerator equals 0. So this has no solutions, which means there are no x-intercepts. So now I'm going to try to graph this. I have a vertical asymptote at x equals 5. And a horizontal asymptote at y equals 0. And I can plot a couple of points if I need to. I have x and 1 over x minus 5. I think I'll just plot maybe 6 and 4 and 10 and 0. Okay, I already know 0 because it's the y-intercept, negative 1/5. If I plug in a 10, 1 over 10 minus 5 is positive 1/5. If I plug in a 4, I get -1, and if I plug in a 6, I get 1. And I just randomly chose some x values. You could pick any x values. You just need maybe a few to give you a sense of what the graph looks like. So I'm going to plot these points. I have 6, 1, 4, -1, 10, 1/5, that's like so close to 0, and 0, -1/5. And then I can try to connect these knowing that the graph will approach the asymptotes. I know that as my function approaches 5 from the right, my graph goes up to infinity. So this is going to go up to infinity like that. And then this will come down towards the horizontal asymptote, and then it looks similar on the other side. So this is going to go down to infinity and up towards 0. This graph does not display any special symmetry. It doesn't have y-axis symmetry or origin symmetry, so we will say it has none. Number 4, j of x equals 1 over x minus 2 squared minus 4. Okay, so the parent function is going to be 1 over x squared, and the transformations are both shifts. I'm going to go right 2 and down 4. So values excluded from the domain would be 2. I can't put x equals 2 in, or I'd have a 0 in the denominator, which means my domain is negative infinity to 2, unioned 2 to infinity. And that means my vertical asymptote is at x equals 2. And then behavior near the vertical asymptote. As x approaches 0 from the right, I'm just going to draw a sketch of the parent function, 1 over x squared. Remember, it looks like this. So, sorry, it's not approaching 0 from the right. It's approaching the asymptote from the right, and the asymptote is at 2. So as x approaches 2 from the right, the graph goes up to infinity. And as x approaches 2 from the left, j goes up to infinity. And then the end behavior at the far right and the far left both go, for the parent, it goes to 0, but I'm shifting this whole graph down 4, so it's going to go to -4. That means the equation of our horizontal asymptote is y equals -4. And then x and y intercepts. So to find y-intercept, we make x 0. So I have 1 over 0 minus 2 squared minus 4. So 1/4 minus 4 is -3.75. And then to find x-intercepts, I make y 0. So I'm going to have 0 equals 1 over x minus 2 squared minus 4. And I'm going to try to solve this for x. So I'll add 4 to both sides. So I get 4 equals 1 over x minus 2 squared. Maybe cross multiply. I'm going to go down into the space below here. So I have 4 times x minus 2 squared equals 1. I could divide by 4. X minus 2 squared equals 1/4. Square root both sides, and I have x minus 2 equals plus or minus a half. And then add 2 to both sides. So positive a half plus 2 is 2.5. Negative a half plus 2 is 1.5. So I have y-intercepts and x-intercepts this time. So now I'm going to go ahead and try and graph this. Vertical asymptote at 2. Horizontal asymptote at -4. And now I can do my x and y intercepts. 2.5 and 1.5 for x. And y is -3.75, almost -4. Okay, and I know that my graph is going to have this general shape, right? It's going to approach the asymptote from the right and from the left, it's going to go up to infinity, and out at the far ends, it's going to approach the horizontal asymptote. So this has to do something like this. It has to come down and approach my horizontal asymptote. It has to approach the vertical asymptote like that. Give that better symmetry. Something, no. Something like that.